Hello everyone. In this video, I want to explain about the storage classes in C language. The basic storage classes are of four. The first one is a auto. Second one is static. Third one is extern. Fourth one is a register keyword. So now the first one is a auto. Next one is a let's take second one as a register. Next one is static. Static, and fourth one is external. These are the storage classes. Now, the title itself is telling that they are storage. They refer to the storage of data, and they are used to perform specific operations on stored data. So they are generally called as the storage classes. Now let us start with the auto. What do you mean by the auto? Auto is a storage class which applicable for local variables of any block of a block nothing but we can able to consider like a function block, a local block. Within that local block, if you declare any set of variable, on that variable we can able to apply the auto. So what actually we'll do by the auto storage class? Now here I want to declare one function. Now in this function I'm declaring some set of variables. That variables are like comes under the integer variable a comma b comma c. These three variables I have created. Now these three variables are local of main function, and by default they are comes under the auto storage class. By default they comes under the auto storage class. And the next, before go to explain about the theme of the auto storage class, let me call you one user defined function. Now here a is equals to something. A is equals to I'm calling add function. Okay, so there here I am passing two parameters, 2 comma 3. I'm passing. Okay, so now this function returning some value. So just let me close the main function. Then I'm calling int add function. Add itself has a two parameters, two formal parameters to access the of two actual parameters that are 2 comma 3. So I'm declaring two formal parameters. So what is the purpose of the two parameters? What is the purpose of these two parameters? To access these two actual values, 2 comma 3, we needed two formal parameters. Now 2 will be stored at x, 3 will be stored at y. Now x comma y are local variables of add method. Now these x comma y are not belongs to main function. They are belongs to add function. So here I am declaring one more variable z. Now I want to execute one expression like a z is equals to x plus y. So now I am returning the return the value of z. Now I'm closing the add function. Then I have created two functions. In these two functions, there we have the respective local variables. This is the end of the program. Now let me explain the same process with memory storage. Now after creating this is, let us consider this is the main block. Within the main block, how many local variables are there? There are three local variables are there. Let us consider them as a, B, C, like that. Okay, there are three local variables are there. There is a one more function. The name is called as a add function. Add function also has a three variables. They are a x, and next one is y and z. There are three local variables are there. Whenever and by default, all the variables are auto storage class. Now by default, nothing but so I want to change the color of the keyword, auto keyword. Now they are by default all local variables are uh, auto storage auto storage class. They are comes under the auto storage class. But I am not explicitly mentioning anywhere in the function. If you not mention the function, auto keyword in the function, even you are mentioning the function, they are comes under the auto storage class. So here it is also auto storage class, but I'm not mentioning the program statement. So that I'm writing the auto in a different color. Now see here, what is the use of this auto created variables? Whenever it is function is calling, the respective a definition will get executed. Whenever it is start executing the definition of the corresponding add function, the memory for x will be created, memory for y also will be created. Whenever function is calling, the variables are allocate with memory. Now this is the x memory, this is the y memory, automatically will allocate, and this is z memory. Like that, even x and y also comes under the local variable category. By default, their storage classes is again will become auto itself. Whenever function is started invoking, immediately the add function get allocated with the three variables. Now the three variables are start get activate and they occupy some memory in the memory space. It's a 4 byte of memory for X, 4 byte of memory for Y, 4 byte of memory for Z. Now they occupied the some memory. They are real entities. They are available in the memory currently. They are comes under the add function and they are local to add function. Now the compiler executing this statement by the statement. Now what is the result of x plus y? The result of x plus y will become a 5 because x value is a 2 and y value is become a 3. Like that, a z value will become a 5. Now 5 we are returning. 5 we are returning. Whenever we are exit from the function, returning nothing but we exit from the function. Whenever it is exit from the function, automatically the memory will be deallocated. Automatically the memory will be deallocated. Whenever control is entered into the definition part of the corresponding function, automatically the memory will be allocated for all local variables. All local variables. Okay. Now, whereas coming to the whenever the control is returning, the function call point, automatically the memory will be deallocated. Memory will be deallocate. So deallocate nothing but which get free. They are going to be free. The xy variable will be removed from the memory. They are deallocate, automatically deallocate after using the function. Okay. So this is nothing but a auto variable storage class property. Whenever control enter into the function, automatically memory will be created for the corresponding variables. Whenever it is leaving from the function, or exit from the function, automatically the memory will be deallocated for the corresponding functions. This is called as a auto storage class related variable, but they are local variables. Even not only for the user defined function, but also it applicable for any kind of function, even in the main. Now, when who will call the main? Compiler will call the main. Whenever it is calling, immediately here the three variable memory will be allocated. Three variable will be allocated. A, B, C like that. They are allocated. Then after executing of this function, finally, whenever you are closing the function, closing the program, or whenever you call for compile and run the code, so we are at the end of the program, we are exit from the main. Whenever we are exit from the main, so these memories are also will be deallocate automatically because we want to make free the memory space. Memory space, we want to keep memory space very and we want to make it is free and make available for using of the same memory for another program or another set of variable. This is a background scenario for local variable by using the auto storage class. So this is all about the auto. Auto means whenever a function or block is calling, then automatically the memory will be allocated for the local variable. When we are exit from the block, automatically the memory will be deallocate for the local variables. This is a basic concept under the auto storage class. Next one is a register. Next one is a register. So I want to remove this remove this one. Next one is the register keyword. Register. In register storage class, in this code, when any variable is declared as a register, that can able to applicable for global variable as well as the local variable. For any variable, we can able to apply the corresponding register storage class. Example, the sub register int a is equals to 5. So now this is the global variable. Now I am declaring some main function. Main function here I am declaring one more variable like register B. into B. Data type is mandate into B semicolon. Now two variables are declared as a register and third variable C comma fourth variable dr are declared for as a normal variable. Now what do you mean by the register storage class? We have a some memory components in the computer. They are basically RAM memory and cache memory. Next one is a register memory. They are temporary memory components. They are usually store the all running programs data. Even in our mobile devices, in laptop, whenever you open a one particular game from your application, your mobile, the app occupy the some memory. The related programs are occupying the RAM memory space. Cache memory is a same like a RAM, but it is along with the processor. It is along with the processor. It's a spare. We can say it's a spare memory, temporary memory space for processor. Like you are carrying a water bottle, and already in your corresponding carrier you have a refrigerator. We are not carrying the refrigerator. We are carrying a bottle. The component of the bottle and refrigerator is water. Refrigerator is water itself. So you can also consume the water from water refrigerator. Also, you can also take the water with the help of bottle. So both are same. The content is similar, but what is the different? The corresponding bottle we can able to carry. We can carry along with us. So by that way, in similar way, the cache memory also a spare memory, a temporary memory for the processor. We have a huge, there is it's a very big concept in operating system and computer architecture and organization. So here I want to give a brief discussion about what I mean by the RAM, what I mean by the ROM. RAM is like a water refrigerator, so which provide the huge memory space. Cache memory provides the less memory space. Both are temporary. But register is a different one. It is also temporary memory, but it's a integrated circuit of a processor to create a memory space. It is an integrated circuit, not along with the processor. It's the integrated circuit in the processor. And it is very fastest memory. It's completely made with a circuit design, circuit communication. Okay, so it is very fastest memory than cache memory and RAM memory because it is embedded in the processor. It's completely embedded and integrated circuit in the processor, so it is become very fast. Whenever you want to use a variable more frequently in your program, and more frequently nothing but every time we are calling the variable, every time we want to call the variable. So that variable we want to write a program that must be run high speed, and there that particular variable must be declared in a register type. In such a way, what happened? The processor can call multiple times the same variable, and but multiple times the speed of access will become very fast because that variable is stored in a register. If the variable is stored in a register, it is very easy to access the data in a very fast manner by the processor. If it is a normal variable, if it is a normal variable like integer, it may be available from the RAM memory or cache memory, which more number of cycles to access the data from RAM memory and cache memory for the processor. Which takes some time more than register. Register is an integrated circuit. So if any variable, if you want to use more frequently in a particular program, better you or allocate the memory in the register. But we are writing a register storage class. Processor will allocate the register memory depends upon availability. We are explicitly mentioning that you have to store this variable in a register memory compiler. Explicitly, we are telling that. But based on the availability only, processor will allocate the register memory for that variable. So our responsibility is that we have to mention that the storage class register. So this is about the register storage class. Now I think you understand. This can be register. Register is a one storage class can be applicable for a global variable as well as a local variable. But auto is mostly it actually belongs to the block wise variable. They are called as a local variable. The next one is static. Next one is static. It's a different kind of concept. Static. So most of the students confusing with constant and static. Static means it may be a constant. It is not a constant. It is also a normal variable. If you declare anything as a static, it is also a normal variable. But using of that variable is in somewhat it is different. Let's discuss about the corresponding concept of static. I want to write a one program which are used to retain the value. So here I am declaring some variable like a int a comma b comma. Always I am writing very simple programs because first I want to make you understand about the concept of everything. Later we can discuss the very big programs. So now I want to call some function like a add function with passing of some two variables, two parameters 2 comma 3. For that I'm closing your main. Now I am calling this add function. Add function with the local variable like int x comma into y. Now definition get opened. Okay. Now, so here I am declaring some variable that is a static. Static int z is equals to 0. Static int z is initialize that I have initialized the value also. Then the expression is z is equal to z plus y. This is our expression. This is our expression. Okay, na? Now, finally, I am returning the result of Z itself. Close this. But here one variable is local variable, and it is declared as a static. What happened whenever a variable is declared under static storage class? Now, let me explain the concept now. Int main, normal declare normal, and then followed by there are three variables are declared, A, B, C are declared. Then we are calling add function, the control transfer to the add function. Whenever it is calling to the add function, control enter into the, our compiler enter into the corresponding add function definition. Whenever it is called, according to the auto storage class, they will get they will get allocate the memory. So what are the variables are get allocate the memory? X and Y are both are automatic variable, storage class variable, auto storage class variable. But Z is not like that. Z is comes under the static storage class. Static storage class. Okay. Now here it is X. Here we have a Y. But Z is not like that. Z is a auto. It is just a static storage class. Now what is the value of X? X value is 2 and Y value is become a 3. Then what is the value of Z? Z initially it is allocated as a 0. Initially it is 0. Now after evaluating this expression, Z value will become a 5. After evaluating that expression, Z value will become 5. Now we are returning the 5. Whenever we are return to function calling method, it's also meaning that we are exit from add function. We are returning to the calling function. Yes, fine. It is also called as exit from the calling function. Whenever we are exited from the calling function, according to the auto storage class, this x and y r should be deallocate their variable memory. They are get deallocate. But here according to the concept, if z also a auto variable, z should also be deallocate. But in this corresponding static storage class, z cannot deallocate the memory, which again retain the same value, even after you are exit from the block. Even after we are exit from the block, which retain the same nothing but the current result of the z. Z still there, still there. It is live. It is not deallocated, it is still there. It is in the live. Even after we are exit from the block, we retain the value. Okay, we retain the value. Then what is the purpose of this kind of variable? Okay, we exited from this function. We exited. Okay, fine. We came to the main function. Again, if you call add, again I'm calling add function. Again I'm calling. This time I'm passing the value of a comma something like a 3, a comma something like a 4 value I'm passing. A is a one local variable. I'm passing local variable as one parameter. Now that is become a C is equals to. Now what is the A value? A value, what is the A value? A value is A value. What is the A value? A value is whenever Z returning the first in the first iteration 2 plus 3 na. So the 5 already returned here. Now this 5 allotted to the A variable. Now A value is become a 5. A value is 5. Okay. Now this 5 value 5 value is passing as a parameter. Now A value is 5. 5 value is become a parameter. Now this 5 value store it to X and 4 value store it to Y. So again we are calling now. Again we are calling. Whenever you call once again the add function, immediately according to the auto storage class, x comma y will get allocate their memory. So now they started working. They are started activation. So now we are get memory for again x comma y. Before that, whenever the control exit in a first call, they deallocated. Now they get allocated x comma y. They become activate. But already Z is in live. It is already retained the value even after exit. Z already there. Now control will come to the static int, but this statement will not execute once again because already it is executed with the first call. Static, the property of static is like that only. Already it is initialized or declared in the first call itself. Whenever we call the second call, static cannot declare the Z once again because already there is Z in the corresponding block. So cannot allocate or initialize the or declare the Z variable once again, which already available with the pi value. Now, whenever you are executing this statement, the result is become the previous value of Z plus and the new value of x is become a 5 and new next to value of y is become 4. Now this is become a output of the next calling of add function. Then what is the value will become 5 plus 5 plus 4. It is become a 14. Now this time the value of z is become 14 plus 14. This is a 14 result. The result is become 14. 14. Okay. Now here it is 5, here it is 4. After executing this statement, again control returning with the 14 value. What is the return value in the second call of addition? 14. 14 is returning. 14 assigned to C. After returning from the add function, a x comma y are auto storage class variable. So they will get deallocate. Automatically they will get deallocate. But Z cannot deallocate. Z is not a auto variable. It is a static variable. It will retain the value of the last modified value, that is a 14. Still it is live. It is there in the block of add. And we are already exited from the block, but Z cannot deallocate. Still it is there. Still it is there. Okay, so in whenever you call once again add function, now Z will get add with 14 plus the new values, 14 plus new value of X and new value of Y. So this is a property of a static. But static can also we can allocate for a global variable. If you allocate static for global variable, we cannot see the any new effect on global variable. Obviously, global variable keep maintaining a new modified value for every time, least last modified value for every time whenever you call you in the some other video already explained about the global variable, the respective properties and modified results. Now here I want to expose only the storage classes. Now we are if any variable is declared with register, sorry, not register, static we can also allocate static storage class for global variable, but we cannot see any new thing or any benefit whenever you declare a global variable as a static. We can see the corresponding actual theme or static theme whenever if you allocate for or apply for the local variable of a function. Okay, you cannot even get error whenever you apply static storage class for the global variable. We cannot see any changes or any new thing, but we can observe the corresponding uh, process whenever you apply static for local variable of a function. This is about the static. The next one is the extern. I will explain the extern in the next video.